Rightio, Lewis. Just looking at this, okay, just a bit of an explanation. You know that when you're plotting the square root function, and this is here, the top branch of it is your y equals, and it is the positive root x, and this branch down here is almost like a separate function. It is y equals minus root x. Yeah, so when you are summing up rectangles, remember that's what integration is, you are summing up these rectangles, you are going to one graph. So when you're square rooting and doing it, you're assuming it's the positive one. Thus, you're summing up all these rectangles to a finite limit, let's say at 5, and then you're going to double it. That's why that one works. Now, if you do it for the one you're talking about, okay, it was plus 1, you said, if I remember rightly. So it shifts it up, translates it up to here, so the whole graph goes up like that. And it should be symmetrical. It looks dodgy, but who cares? Right, and you've got your limit, let's say, to 5. Right, the line of symmetry is just here, so I'm going to choose a different colour. And now we are summing up rectangles between the graphs. That graph there is y equals 1. And this graph here is again y equals positive root x plus 1. Okay, the upper graph we'll call graph 1, the lower graph we'll call graph 2. We are now going to sum up the rectangles that look like that. They're away from the x-axis. So we're looking at that rectangle particularly. It is still delta x wide, but the dimension there is clearly going to be y1 minus y2. So we are now going to sum up, you know the whole process, I'm going to do it long-winded, sum up these strips from 0 to 5. So from 0 to 5 of these rectangular strips, which are y1 minus y2 times delta x. That's the area of one strip. And we're going to see what happens when you take the limits as delta x tends towards 0. And as you know, this thing here, okay, can be replaced with integral 0 to 5 of the function y1. Well, y1 is this upper graph, so it is simply root x plus 1, take away y2, which is take 1. Okay, so you've got that much, and when you're taking the limits, delta x becomes dx to show that you're taking the limits. And you can see what happens is, as you suggested, you are in fact just simply integrating that and then doubling it as you've done before. Okay, and that's how you deal with symmetrical functions like that, or any functions where it's away from the x-axis. All right, I hope that helps. Okay.